Can our brains see the fourth dimension? A four-dimensional space or 4D space is a mathematical extension of the concept of three-dimensional or 3D space. Three-dimensional space is the simplest possible abstraction of the observation that one only needs three numbers, called dimensions, to describe the sizes or locations of objects in the everyday world. The success of 2009's movie Avatar demonstrates that moviegoers appreciate the difference between 2D and 3D, and they're willing to pay a little more for an upgrade. Most of us are accustomed to watching 2D, even though characters on the screen appear to have depth and texture, the image is actually flat. But when we put on those 3D glasses, we see a world that has shape, a world that we could walk in. We can imagine existing in such a world because we live in one. The things in our daily life have height, width and length. But for someone who's only known life in 2 dimensions, 3D would be impossible to comprehend. And that, according to many researchers, is the reason we can't see the fourth dimension or any other dimension beyond that. Physicists work under the assumption that there are at least 10 dimensions, but the majority of us will never see them. Because we only know life in 3D, our brains don't understand how to look for anything more. In 1884, Edwin A. Abbott published a novel that depicts the problem of seeing dimensions beyond your own. In Flatland, a romance of many dimensions, Abbott describes the life of a square in a two-dimensional world. Living in 2D means that the square is surrounded by circles, triangles and rectangles, but all the square sees are other lines. One day, the square is visited by a sphere. On first glance, the sphere just looks like a circle to the square, and the square can't comprehend what the sphere means when he explains 3D objects. Eventually, the sphere takes the square to the 3D world, and the square understands. He sees not just lines, but entire shapes that have depth. Emboldened, the square asks the sphere what exists beyond the 3D world. The sphere is appalled. The sphere can't comprehend a world beyond this, and in this way, stands in for the reader. Our brains aren't trained to see anything other than our world, and it will likely take something from another dimension to make us understand. We spatially perceive ourselves as beings in a three-dimensional space, but visually we are restricted to one dimension less. We see the world with our eyes as projections to 2 dimensions on the surface of the retina. Assuming a 4-dimensional being were able to see his world in projections to a hypersurface, also just 1 dimension less, to 3 dimensions, it would be able to see, for example, all 6 sides of an opaque box simultaneously, and in fact, what is inside the box at the same time, just as we can see all 4 sides, and simultaneously the interior of a rectangle on a piece of paper. The being would be able to discern all points in a 3-dimensional subspace simultaneously, including the inner structure of solid 3-dimensional objects, things obscured from our viewpoints in 3 dimensions on 2-dimensional projections. Our brains receive images in 2 dimensions and use reasoning to help us picture 3-dimensional objects. But, what is this other dimension? Mystics used to see it as a place where spirits lived, since they weren't bound by our earthly rules. In his theory of special relativity, Einstein called the fourth dimension time, but noted that time is inseparable from space. Science fiction aficionados may recognize that union as space-time, and indeed, the idea of a space-time continuum has been popularized by science fiction writers for centuries. Einstein described gravity as a bend in space-time. Today, some physicists describe the fourth dimension as any space that's perpendicular to a cube, the problem being that most of us can't visualize something that is perpendicular to a cube. Researchers have used Einstein's ideas to determine whether we can travel through time. While we can move in any direction in our 3D world, we can only move forward in time. Thus, traveling to the past has been deemed near impossible, though some researchers still hold out hope for finding wormholes that connect to different sections of space-time. If we can't use the fourth dimension to time travel, and if we can't even see the fourth dimension, then what's the point of knowing about it? Understanding these higher dimensions is of importance to mathematicians and physicists because it helps them understand the world. String theory, for example, relies upon at least 10 dimensions to remain viable. For these researchers, the answers to complex problems in the 3D world may be found in the next dimension and beyond. We may be able to understand and learn about this so-called fourth dimension and its properties in the future, but now we can only hope to theorize and think about it. So, what do you think about this mysterious fourth dimension? Make sure to share us your thought about this in the comments section. And don't forget to like, share and subscribe this video if you find it useful.